Okay, number 5. The one that says circle all the expressions? Yeah? Okay. So we have this big long expression, and we need to find expressions that are equivalent to that. So what should I do first to even see what the equivalent answer might be? Well, we're not solving. Solve is with equations. Simplify is with expressions. I know it's a little numismatics, but okay. So if I simplify this, how would you simplify it? What would you do first? Anybody? You combined the parentheses. What do you mean by that exactly? Okay, so you distributed. Okay, distributed. I can go for that, yes. So you distribute here and you distribute here. And what do you get for 3 times 6x? 18x minus what? Yes. All right, so that's what was in the parentheses. And then we have this minus 16x over here. And up in the front, we have 12 plus. Can someone please turn your notifications off or silence them? Can I simplify anything else here? Okay, like, okay, 18x minus 16x. These are like terms, which gives me what? If I combine those? 2x. Okay, and what about the 12s? Can I combine 12 minus 12? Yeah, those are just constants, right? What is 12 minus 12? 0. So we're talking about 0 being added to 2x, which gives me 2x. So I am looking for a simplified expression of 2x with all these other expressions, okay? So who can give me one that is equivalent to 2x that we should definitely circle? D, yes, that is 2x. That definitely should be there. Jamani, are you with us? Okay, what else? Riley, are you with me? Should we just go down each one and check? What is 4x for a minus 2x? 2x, yes. So a should be working, and that should be equivalent. Letter B, what happens when I distribute that? What do you get? 2 times quantity x plus 1 gives me what? Come on, distribute for me, please. What's 2 times x? 2x plus, what's 2 times 1? 2. And then outside of that, we have this minus 2. So if I simplify here, what do I end up with? Can I take 2 minus 2? Or x minus 2? Can I combine those, though? That's an x term with a constant. No. What is 2 minus 2? 0. So these are going to cancel out, and I'm left with 2x. So that one's going to work. All right. What about letter C? Got to distribute. Probably might need a calculator. So use your calculators. Put the phones away. Let's get your heads into this review now. Come on. So what is 15 times 6x? $90x, yes, right, thank you. Minus 15 times 4? 60. And then outside of that distribution, we have minus 16x. Do I have some like terms I should combine? Yeah, I've got 90x minus 16x. When you subtract, you should get, what, 74x minus 60. Is that equivalent to 2x? No, not at all. Not even close. All right, we already said D was equivalent. What about letter E? Is that equivalent? Yeah. No, you've got 90x minus 16x. That's 74x minus 60 again. So that's not equivalent. So that's a big no. And I really like putting x's on stuff that you know do not work. It's a good visual for you saying, don't even think about this one. What about F? No. What about G? Yes, you have 18x minus 16x. That gives you 2x, and 12 minus 12 gives you the 0. 0 plus 2x is 2x, so yes, that works. What about H? 16x divided by 8. What is 16 divided by 8? 2. And you have an x left over, so is that equivalent? Yes. That equals 2x. You can do that. And the last one, 2x plus 8, is that equivalent? No. So the equivalent expressions are A, B, D, G, and H. Okay. All right. How about another question? If I do pass out, go get someone, okay? First one? Okay. Let's see. All right, so we are filling in the missing blanks. These are what shapes that we are looking at? Can you guys get that? Somebody? What shapes are we looking at here? Rectangles, yes. So we are trying to find, here we have a longer side known as the length. Here we have a shorter side known as the width. Yes. Should be in front of that yellow folder, I think, on the right. Is that it? Say review? No? How about the one above it? If that's not it, I might not have any more. I can make you some during my next prep period, which is next period. But I don't think if that's not in the yellow, then I don't think I have any. Because that's the bell work, the notes. So sorry. You want me to sign off on your pass? Yeah. So they know you were here? When will you be able to make this up? Next class period. Thank you. 8, 20, no extras. Okay. All right, so we are looking at length and the width, and you're trying to basically find the area. So with a rectangle, you are taking length times width. Length times width. And we can be looking at the one long rectangle, or you can be looking at two smaller rectangles, okay? So if this smaller rectangle has a length of 9x and a width of 3, what is that area? What is that area of the blue rectangle? Not 26, should be 27x. Yes, you all just multiply. So you take 3 times that 9x. And what about this area, this rectangle in green? What's the area of that? What is it? No? 12. Yeah, you're taking this 3 times this 4. 3 times that 4, because we're just doing that smaller rectangle, is 12. So if I had to talk about the whole area, it would be 27x plus 12, made up of those two smaller rectangles. Okay? All right, how about letter B? Now, letter B, they give you the area, and you have to come up with the width, which is common to both, and the length. So when you have that width that is common to both, what do we call that? It's looking for the greatest common factor. So what is the greatest common factor of 6x and 26? You always start with your smallest coefficient. 6. Does 6 divide evenly into 26? Like, can you take 26 divided by 6 and you get an even number? Not an even number, but a whole number? No. What's the next highest factor of 6? 3. Does 3 divide evenly into 26? No. How about 2? Yes, so we are going to divide by 2, which means that is my common width for both of those. So you are factoring that out. And 6x, factor out a 2, or 6x divided by 2. What do I have left for my length that I'm going to put up at the top? 3x. Yes, 3x. So 6 divided by 2 is 3, and you have that x left. What about 26 divided by 2? What's that? 13. Yes. So the whole length of this rectangle up here is 3x plus 13, and the width is 2. You don't have 3x. You have 6x in the box, right? Really? Did it get cut off, maybe? Or it's just 6 in general. It just says 6 and 26. Oh, well, that would be a mistake. So I would add an x there now, and then divide it by 2. It gives you 3x plus 13. Thank you for letting me know. It's kind of weird. All right. So that probably makes a whole lot more sense now if we put the x there. What about letter C? What do I find for my areas there? How about this first rectangle? Negative 8x, yes, you are multiplying, right? Multiply. And what about the second rectangle? Positive 32, because a negative times negative is a positive 32. Okay? What questions do you have about those still? Is there something that's uncertain for you. Okay. Next question. Yes. Jasmine. Yasmin. Okay. Sorry. Yes. What? Number 2. Oh, yes. This one I like because it's like, oh, it could be appropriate. You have to go to the bathroom while driving on I-465. You're wondering how long it's going to take for you to get to the next exit, which is 4 1/4 miles away. You are timing your progress. You find you can travel 5/6 of a mile in 1 minute. If you continue at this rate, how long will it take you to reach the exit? Okay. So we have, what is this 4 1/4? What does this represent? Is that a rate? Is that a distance? Is that, yeah, it's a distance. Okay. We can travel 5/6 of a mile, 5/6 of a mile in 1 minute. What would this be then? If this is distance, 5/6 of a mile in 1 minute, a rate? Is that what you said? Uh-huh. All right. Do you remember? I don't know that we did a lot with this formula, but maybe in your past, either math or science, something related with distance, rate, and maybe something else? No? Okay. So let's start with our rate. We can go 5/6 of a mile. Okay, so I'm going to say 5/6 of a mile. And how quickly can we travel that? What's the time it takes me to do that? In 1 minute. Okay. So I call this my ratio. For every 5/6 of a mile, that means I've gone for 1 minute, right? They tell me it's going to take me 4 1/4 miles to get to the next exit. Okay. Is that with my miles or is that my minutes? Is 4 1/4 my miles or minutes? Miles. So I'm going to put my miles here right across from my miles here, like of my rate. So this is 4 1/4 miles. All right. And it says, how long will it take you to reach the exit? Well, that's going to be my X. I don't know how long it's going to take. Hopefully I get there before I have an accident. All right. So I'm setting this up. This is your ratio. For every 5/6 of a mile, you have gone 1 minute. I need to go 4 1/4 miles. And I need to figure out how long that's going to take. So I have set this up as a proportion where one ratio is equal to the other. How do you solve a proportion like this? There's a couple ways you can do it. Trying to solve for X. Guys, let's put the phones away, please. Couldn't I cross multiply? Because if these are equivalent, I should be able to take these and multiply and set them equal to each other. So I have 5/6 times X. 5/6 times X is equal to 4 1/4 times 1. All right? 4 1/4 times 1, which is still just going to be 4 1/4, right? What am I solving for here? I'm solving for X, right? So how do I get X by itself? What is happening with X on the side of X right now? It's being added, subtracted, multiplied, divided. Multiplied. So usually we think divide, but we can't divide fractions. What do we do with fractions instead? You cannot divide fractions. So instead we multiply by its reciprocal. What's the reciprocal of 5 over 6? 6 over 5. So multiply by 6 over 5. Multiply this by 6 over 5. On the left-hand side, these all simplify out, and I have x, and I have a slight problem. I have 4 1/4 times 6/5. I need to either put this in a calculator as a decimal, or I need to change it to an improper fraction. Okay, which means you would keep the 4 on the bottom. If you have 4 1/4, that means you have 4 full 4/4. 4 times 4 is 16, plus one more gives you 17. So this is your improper fraction for 4 1/4 times 6/5. All right, so on your calculators, multiply those together. And we are trying to figure out how long it's going to take us to get to that next exit. You guys have some calculators out there, so multiply. Oof. You could simplify a little. 2 goes into 4 twice, 2 goes into 6 3 times. I think you get 51 over 10, which simplifies to 5.1, and this is minutes. 5 1/10 of a minute. Okay? If you want to change your minutes to seconds, you would take 5 times the 60 seconds, because there are 60 seconds in a minute, and in 1/10 of a minute, you would take 0.1 times 60. This is going to give you 300. This is going to give you, the 10th would be 6. So in terms of all seconds, it would be 306 seconds. Okay, if they want it in seconds, don't know that you have to do that. 5.1 should work. But that's how you would convert it to seconds. Okay? So you've got to look for a rate, a unit rate. Says you can travel 5/6 of a mile in 1 minute. That's what you start with. Then take your other mileage in this case, put it up across from the other miles, and then solve for x. Just be careful, if you have fractions, you cannot divide by a fraction. Okay? What questions do you have about that problem cell? Okay, next question. Guys, I'm sorry, I'm not more animated. Yes? 3B. Okay, so before we do 3B, we really need to do 3A. Okay? Do you have an answer for 3A? What is it? 14. Anybody else have an answer for 3A? No? Okay, well, let's check this out. So figure 1. Figure 1, take a look at it, see what you observe. 1 dot. Okay, figure 2. You see, what do you see? because it's what you see in the picture that's going to be important. What do you? Two what? Two dots and what? Two dots were added. Okay, so you're looking from here to here, and you said we added two. Okay. What about from here to here? You take your answer back. Okay. What do you want to change your answer to? Oh. Well, I don't know. It might be right. Okay. So we added two more here. But every time I'm doing this, I have to know what the figure is in front. And that's not very helpful. Okay? So when you are doing these pattern problems, you need to look exactly at the figure number they give you and say, how does this pattern relate to the number 1? How does this pattern relate to the number 2? Because we don't want to be counting plus 2, plus 2, plus 2 in front of all of these. How does this pattern relate to the figure 3? What are you noticing? I don't want you to say you're adding 2. You need to look at figure 3. Do you see something that is 3? 3 dots on the bottom. Right? Does everybody see that? So yeah, that is your initial connection. There are 3 dots on the bottom. Figure 2, how many dots are on the bottom? 2, right? Figure 1, there's 1 dot on the bottom. All right, figure 4. There are 4 dots on the bottom. Okay, so we have something there. Now, how does the row above it, because it's only 1 row each time that's being added, right? How does that compare with your figure number? It's always 1 less, yes. So you have your figure number, okay, your figure number, and on the bottom, that's going to be the number of dots that you have in the bottom row. And in the second row, it's always going to be the number of dots you had in the bottom row, and then what? Number of dots in the bottom row minus 1, right? So if I'm talking about the seventh figure, how many dots are on the bottom row? 7. How many dots are in the row above, which is the number of dots from the bottom row, minus 1? 6. And so, do I add those? Do I multiply? Do I subtract? It says how many dots would be in the total figure. So you would add 7 plus 6 equals 13. So your answer there is 13 dots. You would have 7 on the bottom row and 6 on the second row. Now, they want to know algebraically how many dots would be in the nth figure, meaning we can put any number we want to, but we want to come up with some kind of a pattern or expression. So how many dots would be in the bottom row of figure n? It's n. So how many dots would you have for figure n? Let's try this again. How many dots do you have in the bottom row for figure 4? How many dots do you have in the bottom row for figure 3? For figure 7, it was. For figure n, it should be n. Yes. That's it. We are substituting this in because we are not saying it's a particular value. It's saying whatever that figure number is, it is going to be n number of dots. That's for the bottom row. Okay. What about the second row? How did that relate to the bottom row? Very good. N minus 1. It was 1 less than the row on the bottom, right? So if I am finding the total number of dots, what would I do with those two expressions? What did we do over here? Did we add, subtract, multiply, or divide? Add. So I need to take n from the bottom row plus n minus 1 from the row above it, the second row. Can I simplify that? What is n plus n minus 1? What's my coefficient? Right here. Well, this right here is 1, and when you add them together, yes, you get 1n plus 1n is 2n minus 1. Okay? So the bottom number of dots is the same as your figure value, which in this case was n. The next row above it is always 1 less. Add those together, and that gives you your total. What questions do you still have about that? Just boggles your mind. I can tell you guys are like, If I said figure y, how many dots would be on the bottom level? According to this pattern, it would be y. And the row above it would be y minus 1. You add these two together and it gives you 2y minus 1. Okay? All right. Next question. Next question. Guys, I think you need to try to be working on these a little more. I know you've got other stuff, other classes, but try to take a look at them. Yes, to Marion. I can barely hear you. Did you say 8? Ah, yes, another pattern, everyone's favorite. So using the pattern, Bieschke likes to write, give me the expression for n number. I like to usually put this one first, the b. How many are you going to have for pattern 122? So here's pattern 1. Here's pattern 2. Here is pattern 3. So you want to relate the shape or what you see with the figure number. Let me repeat that. No, don't save it. Stop. Oh, okay. You want to relate the pattern or figure to the figure number. So as you look at the first figure, and then you look at the second, and then you look at the third, do you see a shape besides the heart? Yeah. It is a square. It kind of looks like it's a rectangle, but when you count, it kind of is a square. And what do we know about squares and their sides? Yeah, all the sides are the same length. Okay? All right. What else do you see and observe about these square figures? Cameron? A heart is missing. So how many hearts is that? When you say a heart, that is 1 heart is missing from each square. Okay? So 1 heart is missing from each square. So looking at figure number 1, it should be a square. What are the dimensions of that square? You're like, I don't really see a square. So maybe we'll skip that one for a minute and let's go to the middle one. What are the dimensions of this square that you see? 3 by 3, and then that would give me 9 hearts, but I don't have 9, I have 8. So I have to put 3 by 3 and what? -1. Okay, look at this over here. What size square is this over here? What's the expression I could use to talk about the number of hearts in that square? Say it again. 4 times 4 minus 1. Okay, so let's back up a minute. If this is our figure 1, what should my dimensions be there? If figure 3 was 4 by 4 minus 1, figure 2 was 3 by 3 minus 1, figure 1 should be, look at it. What are the dimensions of that square? 2 by 2 minus 1. Now, how did we get from figure 1 to that expression? It goes up by 1. So if I want pattern number 122, what would be the dimensions of the square for pattern or figure 122? Close. She said 122 times 122 minus 1. Is that correct? For figure 1, did we do 1 times 1 minus 1? For figure 2, did we do 2 times 2 minus 1? How did we get from the figure number to the actual number of the size of our square? Is it going to be 122 by 122? No, because figure 3 was a 4 by 4. What would figure 4 be? What would figure 4 be, guys? Yeah. Say it again. If I have figure 4 right here, what would the dimensions of that heart or that square be for that figure? And -1. So how did you get from figure 4 to it being a 5 by 5? It is 1 more than the figure number, right? Oh, you guys are ready to go. So if it is figure 122, what are the dimensions of that? Yes, 123 by 123 minus 1. And you have to actually calculate that using your calculator. So multiply those together, subtract 1, and you should come up with an answer. Does anybody have that? What was the last 3? 121. All right. So we got through some things, only of the first chapter. Today was supposed to be chapters 1 and 2. So you're going to have to dig in and really try to take a look at these. Tomorrow, you should be looking at Unit 3 on measurement. That was the scaling project, okay? And people had trouble with that, so I definitely want to hit that hard, okay? So I would focus on 3 tomorrow, and we'll try to fit in more of 2 in other places, okay?